All right, good morning, everyone. So today what we're going to do is day 2 of writing equations of inequalities and graphing our solutions. So we're going to start on page 34 in your packet, and it should look like this, just in case it's not page 34, but it should be page 34. And what we're going to do is we're going to go through here, and many of you know when you're looking at this, you might be saying, Mr. Quammen, why is there a whole coordinate plane here? I thought when we do word problems, I thought we only use the first quadrant, and that's true. And partly this is more of like an introduction or a reminder of why we only use the first quadrant. So just deal with me here on these first three, because the whole point is for you to realize and for everyone to realize that we only live in the first quadrant. We only deal with positive values, and everything else here in the second quadrant, third quadrant, and fourth quadrant, we don't use that. So this is where we're going to be living today. So all right, with that said, let's go through and write some basic word problems. Again, on all video lessons, feel free to pause, rewind, listen, ask a partner if you don't understand something. And then I also too will have the notes fully filled out on Classroom, so you can look at those if something doesn't make sense and you can see how it was actually done. All right, so number one, it says a company that manufactures MP3 players, all right, that's just basically the old school iPhone, needs to hire more workers to keep up with an increase in orders. Some workers that they're going to hire will be assembling, and I kind of went over the word assembling the players, and others will be packaging them. So those are the two different jobs. We got assemblers and packagers. The company can hire no more than 15 new employees. So we got a company that's hiring people, and they can hire no more than 15. And the two jobs that they're hiring for are assemblers, or assembling the players and packaging them. So in these problems, in all word problems, we want to figure out what are the variables that we're working with. So here's the deal. The variables and things that are changing are assemblers. So I'm going to do assemblers. So assemblers. So those are people who actually assemble or make. All right, they're actually like making the iPads or MP3 players. And then we have people who packagers. All right, and those are people who put it in the really nice boxes that you buy in the store. All right, now what we have to do is we have to make an inequality. And it's an inequality because we see the word no more, and then there's the word than 15 new employees. So that inequality, what it's going to look like is this: X assembler workers plus Y packagers. These amount of people, when you add them up, these two have to be less than or equal to 15, because no more than means these two X and Y people have to add up together and be 15 or less. So these two values together have to be less than or equal to 15. Now this is what we're going to graph on our coordinate plane. So how do we graph that? Well, if you remember from the last 2 days, we will write equations in one of two ways. Y equals mx plus b. That's how most of our equations were done yesterday. Or number x plus number y equals a number. And this is the form we're going to be in mostly today. This is x and y intercept form. All right, and that means we're going to be making tables and figuring out what our x and y intercepts are from here. So without wasting any more time, let's find our x and y intercepts. So we make our table, and we're going to use this formula. We got x intercepts and y intercepts. And we're going to feel like today, man, every equation is going to be written in this form, and it will be. Many word problems will be written in this form, all right? So I'm a big fan of this form, especially because to find x and y intercepts, remember, that's setting things equal to 0. So if we want to find an x-intercept, we're going to make y equals 0. And if we want to find x-intercepts, we're going to make x equals 0. So what we'll do is we'll take our equation and we're going to substitute zeros in for x and y. So let's start with x-intercepts. So to find an x-intercept, it's going to look like this. X plus 0 is less than or equal to 15. All right. And remember, when finding x and y intercepts, we actually don't even use the inequality. All right. We are going to just make an equal sign. And look at this. X plus 0 equals 15. So that means x equals 15. That is our x-intercept right there. So as I said yesterday, don't wait, plot those down. So 5, 10, 15, that's this big thick line right here. That's 15, all right? And so that's our x-intercept, and actually I'll do that in colored so we can see it. So x-intercept assemblers, that's there. All right, and then our y-intercept, all right, we make x 0. So check this out. We're going to go 0 plus y is less than, but again, just make it equal to 15 because we're finding an x-intercept. So this means y equals 15. Boom. All right, and that's people who package. So these 15 people, again, 5, 10, 15, boom. There's our inequality. Now, we've graphed this. Now, if you remember from yesterday, there's two things that we have to remember when doing inequalities, when graphing inequalities. It's the type of line. So number one, it's the type of line, all right? So in this case, because it's equal to, this is a solid line. So we're going to make a solid line, and we're not going to continue to the line down here because you can't hire negative people here, and you can't hire, even though this is positive going up, but over here it's negative. So we are living right here. So our answer today is going to be living in this quadrant. All right. So now we got a solid line. What we need to do is we need to determine, because it's an inequality, where we shade. So number 2 is shade. Now remember, with the shade, we need a test point. All right, so test point. Now our test point is a point that's not on our line. And we said yesterday that one of the best test points you can ever have, and I'm going to label it TP, is 0, 0. So what we're going to do is we're going to use 0, 0, and we're going to put it into this equation. All right, we're going to put it into this equation, and we're going to see what it spits out. Does it give us a true statement or a false statement? All right, so when we put in 0, 0 here, so let's take this here. So 0 for x, 0 for y. So it's going to be 0 plus 0 is less than or equal to 15. You do need your inequality when you're testing it out. So you're going to get 0 is less than or equal to 15. This is true, which means that this is the true side. The test point side is true, and this is the false side. So my question to all of you, if you remember from yesterday, is what side do we shade? Do we shade the true or the false? And the answer is true. So this would be our answer to this inequality. We wrote our equation. We found our x and y intercepts. We have a solid line because we have equal to, and we tested our point to determine what side of our line we shade, and that's our true side. All right. Now, again, because we've already learned about we live in the first quadrant, we will make everything in the first quadrant and we don't extend past it. And we make sure that our shade, we don't cross the x and y axis. Okay. All right, let's try another one. So the class president had asked you to make delicious cupcakes for a fundraiser. With the fundraiser fast approaching, you have asked some friends to help you out. Hold on, let me get a pen. All right. Some friends that you asked to help out will frost the cupcakes, and others will decorate the cupcakes. Ooh, so those are the two jobs people will be doing. So I'm going to write those things out. Those are the two different things that are going to change. So frost cupcakes. All right. And we have decorate cupcakes. All right. And these are people who are going to do this. All right. These are people who are going to do this. So let's continue reading. Now it says, it says at most 5 friends. So at most, that's your inequality. At most, 5 friends have agreed to help. So that means no more, like at most means 5 or less friends have agreed to help. All right. It says write an inequality that describes the number of friends who can assign to each task. So here's the deal. Ready? Frosting people and decorating people, x plus y, have to be something to 5. So if you have at most 5 friends to help, that means these two different types of people who are going to help in different jobs have to be less than or equal to 5. Now, I'm going to show you something kind of cool. All right. Whenever your equation is written in this form, x plus y, and then inequality, a number, your x-intercept, all right, and your y-intercept are always going to be whatever this number are if there's only the number 1 out in front of your x and your y. You see that? So if you were to substitute in 0 for both of these, you would get an x-intercept right here of 5, 0, and a y-intercept of 0, 5. This is like my favorite way equations can be written, and a lot of real-world inequalities are written that way. So we have 2 inequalities or 2 points that we're going to graph, 5, 0, and 0, 5, that's up here. So those are your two x and y intercepts, and these are the friends that are going to help, right? And now we look at the two things that are unique for inequalities. The type of line, so because it has the equal to sign there, that line under, it's going to be a solid line. So we're going to put a solid line here, boom. And again, we are living in the first quadrant. We are living in the first quadrant, so we are not going past the first quadrant here, all right? So what we have to do is we have to choose a test point. And here's our TP, our test point of 0, 0, because our line doesn't go through it. And we're going to test to see what side we go in or we shade to. So we're going to go 0 plus 0. So 0 plus 0 is less than or equal to 5. 0 plus 0 is 0 is less than or equal to 5. And is 0 less than 5? Now, remember yesterday we were having some issues with this. So turn it into dollars. Now, $0 less than $5, and that's true. We seem to get this right every time when we thought about it as money. So talk about it as money. So our test point side is true, and then on the other side it's false. And again, what side do we shade? It's always going to be the true side. So we are going to shade this, all right? Now, I do want to go back and talk about some of this because I'm not going to do another one, but I do want to talk about this. So when we were graphing linear equations, so equations, we didn't shade, and we didn't have to worry about the line. But what I want you to understand is that now that we have a shaded area, all right, our answer is not just the line, but our answer can be anything inside this shaded area. So anything inside of here, these are answers. So possible answers. And if you're like ANSWERS, all right, if you're like, what do you mean they're possible answers, Mr. Quammen? I don't get it. Well, they're possible combinations of things. So, for instance, in this first one, we were talking about people who will assemble, like build MP3 players, and people who will package. So, if we were to choose a coordinate, all right, now I know I wrote some stuff on here, so let me see if I can move some of this to get it out of the way. Get rid of you, get rid of you, even get rid of this. Oop, I want to leave that. Okay, here, what I'll do, and I know y'all can see this point. You see this point right here? This point right here is 5, 5. Now, 5, 5, what that means is 5 assemblers and 5 packagers. That's what X and Y means. So if you think about it, in the problem, it said that these two values, packagers and assemblers, people that you hire, have to be less than or equal to 15. Is 5 plus 5 less than or equal to 15? And that answer is yes. So that's why we shade. We shade because any number of possibilities of people you hire. So here's another one. All right. This point right here. All right. It's hard for you to see, but this point right here is 2. I think it's 212. All right. 212 means 2 assemblers and 12 packagers. If you add these two up, is that still less than 15? And it is. That works. So any point that is inside your shaded area is also a true solution. And that's why it's so important to shade and know which side you have to shade based on your test point and making your inequality sign. Okay? So this is what I want you to do. I want you to pause the video and I want you to see if you can do number 3, right? When you stop the pause, you can see if my answer and your answer are the same. Ready? Pause. All right, here we go. Ready? Susie's trained for a triathlon and she wants to bike and run on the same day. She has to work out more than 3 hours each day. Write and graph an inequality. So here we go. We got 2 things she's doing. She's got biking, so bike, and here it is, bike hours, because she's it's how much time she's doing stuff for, and run hours. And it says she has to run more than 3 hours each day. So this is what it's going to look like. X plus Y. So bike hours and run hours. And she has to run more than, so this has to be greater than, all right, 3. Now it's not or equal to. It says more than 3 hours each day. So we have to do just greater than. Now notice, this is still written X plus Y with no numbers out in front. So our x-intercept is whatever this number is. So it's 3, 0. And our y-intercept is 0, 3. All right, our y-intercept is 0, 3. So 3, 0, 0, 3. And now we have to ask yourself, all right, it's an inequality. What type of line do we have? Now, because there's no equal to, it's dashed. So let's get some practice. Dashing, dash, 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 dash. All right. Now the dash means that that line is not included in our answer. Only the shaded area will be. And now we're going to test point. All right, let's test it out. Ready? TP. So we're going to test out 0, 0. So we'll put 0 in here. Ready? 0 plus 0 is greater than 3. Is 0 greater than 3? That is false. So we got false inside here. I'll put a big F inside here. That means the other side of our line is true. So check this out. What we're going to shade is this area. Everything outside here is a combination of run hours and bike hours that are greater than 3. All right. So this over here. So again, if you were to choose a point, let's choose a point here. How about this one? This is a fun one. All right. What is it? 6. This is 6, 6. So think about it. 6 run hours and 6 bike hours adds up to 12. Is that greater than 3? Check. So that's why the shaded area is so necessary. So down here on our notes, it says, so far, what have we noticed about graphing inequalities from word problems? What part of the graph do we use? Well, we always use quadrant 1. And the reason it's quadrant 1, it's all positives. It's very rare that we're going to do stuff with negatives. The only time negatives really come in is with money, right? You can't have negative friends or negative cupcakes or negative anything besides money. So we're always living in quadrant 1, all right? So here's the deal. We're going to flip, and we're going to do one more problem, all right? We're going to do one more problem. And what we're going to do is we're going to do problem 4, all right? So problem 4, and then I'm going to ask you to try another one, and you can check your answer on Classroom and then start some homework. So here we go. Now, this one is not going to be x plus y. We're going to have numbers out in front. So let's see what's going to happen here. Ready? So it says, at Jim's greenhouse in early spring, there are many plants and flowers to repot. It takes Jim 5 minutes to repot a plant and 2 minutes to repot flowers. So there's 2 types of things that he's repotting, and this is what we're comparing in this problem. Jim has at most 2 hours, also known as 120 minutes. All right. So when we do this, we got to also make sure that we are in the same units. So even though they gave us hours, since these two are talking about minutes, we need to convert 2 hours to 120 minutes. All right. And he has 2 hours before the greenhouse opens. Write and graph an inequality that represents the time Jim has to repot plants. All right. So look at this again. Plants and flowers. So notice in the question, they will tell you what the 2 inequalities we're going to be working with. So here we go. Ready? So first off, X is going to be number of plants, and Y is going to be number of flowers. All right. And this is what we're repotting. Now, it's not just 1 and 1. We have a time restriction. So here's the deal. Ready? If we're dealing with plants plus flowers, and then we have to deal with at most 120 minutes, this has to be less than or equal to 120. But, all right, plants and flowers, if we're talking about time, we have to talk about how much time it takes to plot a plant. So this is going to be 5x and then plus 2y, because 5 minutes per plant plus 2 minutes per flower has to be less than or equal to 120 minutes. That's all he's got. All right. So this is our inequality. Now, because this is real life inequality graphing, what we need to do, all right, notice here, all right, is we need to do our 2 things from the past. We need to label, all right, so we're going to do this number of plants, all right, and then over here we have number of flowers. Now, we might have to scale, but we have to figure out what our x and y intercepts are. Now, notice here, our x and y have coefficients, so we're actually going to have to use our table and solve these. So we got x-intercept, y-intercept. Again, to find all x-intercepts, we make y equals 0. So we're going to do that. Ready? 5x plus 2 times 0 equals 120. 2 times 0 goes away, so we get 5x equals 120. And then we're going to divide. So on your calculator, you're probably going to need that. 120 divided by 5. All right, divide by 5, divide by 5, and you're going to get x equals 24. Now, I know and you know that we don't have 24 boxes here on the x-axis. So we're going to wait. We're going to wait until we finish the y's, and then we'll scale. So the y-intercept, we're going to make x equals 0. Okay? So we're going to make x equals 0, and here we go. 5 times 0 plus 2y equals 120. 5 times 0 goes away. So 2y equals 120. Divide by 2, and we're going to get y equals 60. Now, we are definitely going to have to scale here. So what I want to do is, since there's a lot of stuff going on and this sometimes gets tricky, let's just make our numbers really super easy. All right? Since we're scaling to 24, I know a lot of kids are like, make everything go by 2. I'm going to show you the easiest thing for me. All right? I'm going to do this. Ready? 5, 10, 15, 20, 25. That works because guess what? Just before 25 is 24, and there's my x-intercept. You see that? Now I'm going to do the same thing with y's, but I'm going to do it even easier now. Watch. Since I got to get to 60, I'm going to go 10, 20, 30, 40, 50, 60. And look at this. I have my y-intercept here. All right? Don't overthink these things. Just try to make it as easy as possible. As long as you start at 0 and you go by the same amount of numbers with the same amount of spacings, right, you're good for both x and y. Now notice my x's go by 5, my y go by 10. It doesn't matter. As long as all your x's go by the same, you're good. So now we need to graph and shade. Those are the two new things, right? So because we have an equal to, this is going to be solid line. We got a solid line here. And then we need to shade. So what we're going to do is we're going to do a test point here. I'm going to make 0, 0 my test point, and I'm going to test. Now I'm kind of running out of space. So look what I'm going to do. I'm going to take my equation, all right, and I'm going to come down here. So check out what's going to happen. I got 5 times 0 plus 2 times 0 is less than or equal to 120. I love when it's written in standard form like this because 5 times 0 is 0, 2 times 0 is 0, and so you're going to get 0 is less than or equal to 120. This is true, which means this is your true side, this is your false side, and you only ever shade with inequalities the true side. You see that? That's your true. So this is your graph, labeled, scaled, everything. And if you got this, you're crushing it. So we do have one more question, and that's kind of covered up by this. So check this out. It says, if Jim has 20 plants to repot, what is the maximum number of flowers he can repot? So here's the deal. He's got 20. Now, it's kind of tough to see down here. So what I'm going to do is I'm actually going to make a better line. And let's see if we can figure this out. So if you look, all right, maximum number of flowers. Now, it says that he has 20 plants to repot, 20 plants. So here's 20, boom, right here. So if you go up, it looks like it might be 10, right? So what we have to do is we have to test this out in our equation up here. So if we got 20 plants, so it's 20 for x, we're going to go like this. 5 times 20 plus 2y is less than or equal to 120. 5 times 20 is 100, 100 plus 2y is less than or equal to 120. Subtract 100, and what you're going to end up getting, I'm running out of space, all right, is you're going to end up getting over here 2y is less than or equal to 20. Divide by 2, and you get y is less than or equal to 10. So the answer, like we could see here, is 10. So we can say 10 flowers is your maximum. All right, and I checked it both from my graph and from my equation. All right, so this is what I'm going to ask you to do. All right, I want you to try number 5. All right, but number 5, very similar. All right, you're going to have to look on Google Classroom. Google Classroom, I put the answers to the notes, and I put the answers to the homework. So please check that. And if you're good, go into the homework, which I believe is the next page. And it's going to look like, nope, those are my answer keys. All right, which is going to be right here, day 2. Okay, so please make sure you're doing that and you're checking your answers. Well done, everyone.